Hello dear learners, welcome back to my channel. So today in this video we'll be discussing about the image formed by a convex mirror. So in the previous video I've discussed about image formation by a concave mirror. So in order to understand the image formed by a convex mirror, first we have to learn the rules. So we'll start with the rules and then we'll discuss about the image formed by a convex mirror. Okay, so rule number 1, it says that if the incident ray is parallel with the principal axis, then the reflected ray appears to diverge from the focus. So we know that convex mirror is called as a diverging mirror. It has reflecting surface outwards and it diverges the rays that falls on it. So you can see in this diagram, so we have a convex mirror here. P is the pole of this mirror, F is the focus and C is the center of curvature. And this line which passes through pole and center of curvature, we call it as the principal axis. So the incident ray that we have taken here, the incident ray, the ray which is going towards the mirror is called as the incident ray. So this ray which is going towards the mirror is parallel with our principal axis. So the rule says that if the incident ray is parallel with this principal axis, then the reflected ray will appear to diverge from the focus. That means it will appear to come from the focus. So it will go in this direction after reflection. So if we produce this reflected ray backwards, then it will intersect or it will meet at the focus. So it appears as if this reflected ray has originated from the focus or it is going from the focus. So this is rule number 1, which says if the incident ray is parallel with this principal axis, reflected ray appears to diverge or come from the focus. Now let's discuss rule number 2. Now rule number 2 is just the opposite of rule number 1, same as concave mirror. So in rule number 2, it says that if the incident ray is going towards the focus, it is moving towards the focus, then the reflected ray after reflection becomes parallel with the principal axis. So here you can see that our incident ray in this case is moving towards the focus. It is going towards the focus. You can see the dotted line. It is a straight line here. So it is going towards the focus. But since the reflecting surface is outside, so the ray gets reflected from the mirror from this point and it moves in such a way, or it gets reflected in such a way that it becomes parallel with our principal axis. So the rule says that if the incident ray is moving towards the focus, then after reflection, the reflected ray will become parallel with our principal axis. So this is our rule number 2. Okay, now the third and the last rule that we must remember for image formation by a convex mirror. The rule says if the incident ray is moving towards the center of curvature, if the incident ray is going towards the center of curvature, then after reflection, the reflected ray will follow the same path backwards, or we can say it will retrace the path. So here in the diagram you can see that our incident ray is going towards the center of curvature. Now as soon as it strikes the mirror, it follows the path in the backward direction. That means the reflected ray will move in the same path but in the opposite direction. It will retrace the path. So rule number 3, if the incident ray is going towards the center of curvature, the reflected ray will retrace its path. So this is rule number 3, and with these rules we can form the image by a convex mirror. So this is the first case of image formation by a convex mirror. So in the first case we are taking the object which is placed at infinity. So the first case that we will discuss is when the object is kept at infinity, what kind of image will be formed by a convex mirror, what will be its position and what will be the size. So we have already discussed that whenever an object is kept at infinity, infinity means a large distance, then the incident ray will always be parallel with the principal axis. And for image formation we need at least 2 rays. So here, since our object is kept at infinity, we will take 2 incident rays which is parallel to the principal axis. So let's draw the incident rays first. So we can consider 2 incident rays and these incident rays will be parallel with the principal axis. The simple reason is because our object is at infinity. So here in the diagram, you can see that we have drawn two rays, two incident rays, and these incident rays are parallel with our principal axis. So in order to form the image, we will use rule number 1, which says that if the incident ray is parallel with the principal axis, then the reflected ray will appear to come or appears to diverge from the focus. So if you look at the first incident ray, after reflection it will move in this direction such that it appears to come from the focus. So it will get reflected in this direction. And the second incident ray, after reflection, it will go in this direction. You can start the line from the focus, because when you bring it backwards, it will intersect the focus. So these are the two reflected rays. So this is the first reflected ray and this is the second reflected ray. Now here, the thing that you have to note is the two reflected rays, they are not intersecting with each other. We know that images are of two types, real image and virtual image. Real image is formed when the two reflected rays actually meet or intersect. But if the rays doesn't intersect with each other, then we have to produce them backwards and make them intersect. In that case, the image formed will be virtual. So it is very clear that in this case, image cannot be real because the reflected rays are going in different directions. They will never intersect each other. So what we will do, we will produce these reflected rays backwards. So we will draw this line in the backward direction. So let's draw it with the dotted lines like this. And similarly, this reflected ray, you have to produce it backward. So when you produce these reflected rays backwards, you will see that the two reflected rays will intersect at the point F. And it is at this point F that the image of a distant, that is object at infinity, will be formed. Now let's look at the three things: position of the image, nature of the image, and size of the image. Now it is very clear that our image will be formed at the point F, that means at focus. So position of the image will be at F, because the two reflected rays after produced backward will intersect at the point F. So that will be the position of the image. Now nature of the image, as I said, since the two reflected rays are not intersecting each other, the image formed here will be a virtual image. So the image will be virtual, and virtual image will be always erect. So you can write virtual and erect. Now the third thing is the size of the image. So since our image is formed at F, it will be a point size image, or we can say that the image is highly diminished. So here you can write down the size of the image as point size, or you can also write it as highly diminished, right? So you can draw the diagram properly in your copy. So this will be the direction of the reflected ray here. So this is the first case where we have object at infinity and the image will be formed at the focus. The nature of the image will be virtual and erect. Virtual because reflected rays are not intersecting each other. They will intersect when produced backwards. And the third thing, size of the image, it is a point size image. Now the second case, so here we are keeping the object between infinity and the pole of the mirror. The first case was object at infinity. The second case is object between pole and infinity. So in this diagram, you can see that we have an object which is kept between pole and infinity. So for this object, we need to form the image, and for that we will use the rules. Now for image formation, we must have two rays. So we will take the two incident rays and we will use the rules, and we will see the reflected rays for this case. So first, let's take the incident ray parallel with the principal axis. So out of two incident rays, I am drawing the first one. So this first incident ray, as we can see, is parallel with the principal axis. Now using rule number 1, which says if the incident ray is parallel with the principal axis, reflected ray appears to diverge from the focus. So this ray, after getting reflected from the mirror, will go in this direction, and it appears to diverge from the focus. If you draw this line straight, it will reach the focus F. So this is the first incident ray parallel with the principal axis, and according to rule, it appears to diverge from the focus. Now second we will use is the ray which is going towards the center of curvature. So let's draw another incident ray which is going towards the center of curvature. So here if you use sharp pencil, then the image or the diagram will look better. So here we have the second incident ray, and this second incident ray is going towards the center of curvature. If you draw the line continuously, it will reach the center of curvature C. Now the rule says if the incident ray is going towards the center of curvature, then the reflected ray will retrace the path. So reflected ray will move in this direction. So here again we can see that there are two reflected rays, and these two reflected rays are going in different direction. That means there is no chance by which they can intersect with each other. So what we will do here again, we will produce these rays backwards, and we will see where the two reflected rays produced backwards will intersect. Wherever they intersect, that will be the position of our image. So let's produce the reflected rays backwards. So let's produce the first ray backward. So let's do it with the dotted line. So this is the first reflected ray when produced backward. As you can see, it appears to diverge from the focus, and if you draw this line further ahead, it will reach the center of curvature. We can draw it with dotted line here again. So you can see that we are producing the reflected rays backwards. So when we produce this reflected rays backwards, they will intersect at a point. So at this point, the two reflected rays are intersecting. You can see that the dotted lines are intersecting here. So wherever they intersect, that will be the position of the image formed. So what we will do next, we will simply drop a perpendicular on the principal axis, and this will be the position of our image. So this will be the image of our object. Now let us look at these three things. So where is the image formed? First of all, if you simply follow the rules, you don't have to worry about the position of the image. Automatically it will be at its own position, so you don't have to memorize. So here we can see that the image is formed between the pole and the focus of the mirror. So the image formed is between pole P and focus F. Second thing, what is the nature of the image? As this image is formed when reflected rays are produced backward, the image will be virtual, and virtual images are always erect. So here we can write virtual and erect. And the third thing, size of the image. Now if you compare the size of the object with the size of the image, we can see that the size of the image is smaller than the size of the object, which means the object size is bigger than the image size, or else we can say that the image is diminished. It has become small. So in the second case, when object is between infinity and pole, what do we find? Using the two rules, we will form the image first, and we will find that position of the image is between pole and the focus of the mirror. Nature of the image will be virtual and erect because it is formed due to interaction or intersection of the reflected rays when produced backwards. And the third thing, the image size will be smaller than the object size, which means image will be diminished. So in convex mirror, we have only two cases. The first case when object is at infinity, and the second case when the object is between pole and infinity. Alright, so this case is important for the convex mirror. For concave mirror, the last case is important when object is kept between pole and the focus, because that is the only case where a concave mirror forms virtual and erect image, whereas convex mirror always forms virtual and erect image. Alright, so that's all for today. Please do subscribe my channel and share it with your friends so that they can take the advantage, they can learn the lessons properly and prepare well for their board exams. Thank you everyone.